Okay, now we move on to topic D, where we're going to do a lot of estimating and application of all the work we've done so far. First, we're going to start thinking about fractions in terms of some benchmarks. And those benchmarks are on this chart right here. Fractions that are close to 0, fractions that are close to a half, and those that are close to 1. And then we want to divide that up a little bit more even and think about fractions that are a little bit less than a half or fractions that are a little bit more than a half. Fractions that are a little less than 1, fractions that are a little bit more than 1. So if you're thinking about a number line, we want to know what fractions are way down here, what fractions are a little bit less than a half, which ones are a little bit more than a half, which ones are up here close to 1 but a little less, and which ones are a little bit more. Because we want to have a sense of, oh, that's about 1, this is about a half for what we're going to do later. So we give them a lot of fractions, we put them out there, and then kids have to talk to each other and figure out where they would go on this chart. And the ones that they put on close to 0 will be fractions like this. 2/11, 1/8, 17/936. And the ones that they'll put that are a little less than half look like this. 3/8, 7/12, 31 60 maybe 15 31ths. And the ones that are a little bigger than a half would look like this. Oh, sorry, I put one over there. 7/12 would go over there. 21/40 would go over there. 8/15 would go over there. Then we want ones that are a little bit less than 1. Something like 16/17, 8/9, 30/33s, something like that. And the ones that are a little greater than 1, 9/8, 15/13, 12/11. And once we've sorted them this way, then we want to help kids to define it. How can we tell? Rules that we can use to help us look at fractions and know exactly where they fit on this chart. And they come up with 3 rules. And the rules are these. Fractions that are close to 0 have a numerator that is very small compared to the denominator. It's really important that we talk about that part about how it's compared to the denominator. Because if we just look at that, 17 is not really a very small number. But when you compare it to 936, it is a very small number because it means that we've divided something into 936 parts. So those pieces are going to be very, very small. And we only get 17 of them. It's practically nothing. So that's the rule for a fraction that's close to 0. Very small numerator compared to the denominator. When we get to fractions close to 1/2, what kids notice is the numerator is always about half of the denominator. 7 is about half of 12, 21 is about half of 40, 8 is about half of 15, 15 is about half of 31, etc. And the way that we can tell if it's a little less is if we double the denominator, double 3 and I get 6, that's a little less than 8. Double 31 and I get 62, it's a little less than 63. But if I double 7, I get 14, that's a little more than 12. So that helps us know which side of 1/2 it goes on our number line. Then we notice our third principle, principle C, and that is that a fraction is close to 1 when the numerator and the denominators are almost equal. 16 is almost equal to 17, 8 and 9, 30 and 33, 9 and 8, etc. And again, we can tell if a fraction is a little bigger than 1 or a little less than 1 because the numerator will be a little less than the denominator if it's less than 1, a little more if it's more than 1.